Servant.
Very good morning to all, and welcome to this session. Today we are going to discuss the simply supported beam with the 2-point loads. It's a problem solving session. In the previous class, the same simply supported beam is solved with 1-point load. Now, with two point loads with two different locations. How to draw the shear force diagram and bending moment diagram. This is the today's task. We are going to do that. Okay. As said, here is the simply supported beam. At point A, you have a support reaction RA. At point B, another support reaction. So I am having RB. And I have only two loads at point C and point D. Okay. For this, how the shear force and the bending moment diagram will be there. Okay. First, we have to find support reactions. Support reactions we formed by equilibrium equations. We have only vertical loads. Simply I will take sigma b is equal to 0 with the sign convention. Upward force is positive. Okay. So we have RA plus RB. And two different loads, 20 plus 20, and they are down loads. So simply it is equal to 20 plus 20, that is equal to 40 kilonewton. Okay, RA plus RB equal to 40 kilonewton. Out of this, what about the RA and RB contribution? They will take care of the loads. Okay. So let's move on to using the another study the equilibrium equation. That is the alternate sum of the bending moment at any arbitrary point that is equal to 0. At arbitrary point, I have already told that to take where the simply support, that is support is there, that point I am taking. Either A or either B. This time let's move on to the support B. Okay. And what is the sign convention for bending moment? Clockwise is positive, anti-clockwise is negative. According to my sign convention. Okay. Bending moment at point B. Now all the forces here are traveling to point B. Okay. Force into perpendicular distance. So with the sign convention, whether all the forces RA travels to point B. So it is clockwise manner. 20 kN travels to B anti-clockwise. 20 kN downward action force anti-clockwise manner. Okay. So for that, I am taking RA into the distance is 2 plus 2 plus 2. So total is 6. And this is moving on to the point B anti-clockwise taken as negative. And 20 into what is the perpendicular distance? 20 into 4. And this 20 kN also downward force and travel to point B in the anti-clockwise manner taken as negative. It is also 20 into the perpendicular distance from this point to B is 2. That is equal to 0. And here it is 6 RA minus 80 minus 40. That is equal to 0. So total it is 6 RA equal to 80 plus 40 120. So RA equal to 20 kilonewton. Okay, RA equal to 20 kilonewton. If I take the support, this point as taken as MA is equal to 0, sigma MA is equal to 0, I will get RB is equal to 20 kilonewton. Okay, let's check whether RB we are getting the same 20 kilonewton or not. So RA plus RB is equal to 40 kilonewton. Then RB equal to 20 kilonewton. Okay. So just I write here is 20 kilonewton RB. RA equal to 20 kilonewton. Now let's move on to finding the shear force values. shear forces. So sign convention is right out is positive. Okay. So vice versa, everything is then opposite of this one is negative. Okay. Further, I have to have the reference point. Okay. So FB, I'm taking right side, cancel right side, right output is positive. So 20 kilonewton. Next, F at T point. So this is positive, this is downward action, right down. Negative. So 20 FD equal to 20 minus 20, that is equal to 0. Then F at the C point. F at C point, cancel right side once again. So 20 minus 20 and minus 20. So 20 minus 20 and minus 20, you will have minus 20 kilonewton is the shear force value at the point C. And what about FA? Cancel left side, so left up is negative. So that is equal to 20 kilonewton, left up is negative, 5 minus 20 kilonewton. So the values are found out. So in shear force, so 0 shear force line, and at FB that is equal to 20 kilonewton. And at FD that is equal to 0. FC that is equal to minus 20. FC also minus 20. So there is no UD delta, so directly join, horizontal join, where the what is there, join vertically. Okay, here I use different color. And at FC you have minus 20. So you don't go for directly join, go for horizontal line because it's only point load. And then where the point load is acting, you have draw a vertical line. And in between, only the same. Now you just close it to the 0. So this is the shear force line. So this is negative, this is positive. In between C and D, there is no shear force at all. That is value equal to 0. FD equal to 0. So this is the shear force diagram. Then we can move on to the finding the bending moment at each and every point. So let's take BM. So M at the point B, force into perpendicular distance. So M is equal to 0. Since you are having only one force lies at the same point 0, that is, then we can go for the bending moment at point D. So RB into 2, and this 20 will not have any effect because it lies at the same point. Simply it is 20 into 2. But what is the sign convention? Upward force will produce the positive bending moment. There is the concept here. Since this 20 is 20 kilonewton is positive, so upward force it produces positive bending moment. So 20 into 2, that is equal to 40 kilonewton meter. And what is MC? Okay, now instead of going this side, you can go for the other side also. Okay. So MC from the reference line, just go for the left. Now only one load RA. So RA to is C point. You have only 2 meters. So RA into 2 meters. Since RA is upward force produces positive bending moment. So 20 into 2, that is equal to 40 kilonewton meter. Okay. So LB, LB, LC. What is MA? Consider the same reference point. Consider the left side, you have only one point load RA lies on the same point So don't have any perpendicular distance, that is equal to 0 bending moment value. Okay. Now let's draw the bending moment diagram. So this is a 0 bending moment line, bending moment diagram line. MD is equal to 0. MD equal to 40 km. So it is 40 km. And MC is also 40 km. The same value. And MA, that is equal to 0. Okay. For bending moment diagram with the point loads, we have to draw the direct joining of 2 points. Okay. This point is point. But the bending moment point is there is no another unit at all. So here it is direct joining of 2 values. Both are same. So it should be a horizontal line. And at this point to this point you have a 0 line, 0 value. Draw this. Okay. So all are having positive values. So this is the bending moment diagram for the given simply supported beam with the 2 point nodes at C and D. Okay. So this is the bending moment diagram, and we have to see another simply supported beam with the number of loads with UDLs and UDLs in the next classes. Thank you.